cuts, burns, amputations, exposures to hazardous substances, electric shocks, asphyxiations, and drownings are just some examples of consequences that can occur when work is carried out on plant and equipment that has not been properly shut down. The shutdown or isolation of plant and equipment before work is carried out is commonly referred to as a lockout or a lockout tagout. Lockouts usually occur for maintenance, repair, or service work. The purpose of a lockout is twofold. First, to remove or neutralize all hazardous energy sources that are present. And second, to prevent the accidental activation of any hazardous energy source until the lockout has been completed. In other words, a lockout is a planned event to isolate, block, dissipate, and control all hazardous energy sources. Lockouts are important for maintaining safe working conditions and should always be strictly enforced. Every machine, piece of equipment, device, or process that requires a lockout should be identified and a specific lockout procedure written for each. This procedure should include the following detail: the name or the job title of the person who has overall responsibility for ensuring the lockout is properly performed. For example, the site supervisor. This person is often referred to as the lockout coordinator. A description of the person or people responsible for performing the actual lockout. For example, the operator and an electrician. The energy sources that need to be controlled. The location of all energy sources, control panels, switches, interlocks, valves, bleeding points, and blocking points. A step-by-step guide to what should be done in what sequence and who should perform each step. A step-by-step guide to test that the lockout procedure has been completed successfully. And a step-by-step guide for removing the lockout when the work has been completed. The written lockout procedure should also include all requirements for personal protective equipment that must be used during the lockout. Details of any special hazards that exist, such as the presence of hazardous substances, and information on how the lockout is to be safely maintained if it is extended into a new work shift. Lockout procedures frequently address a number of different energy sources and often combine a number of different methods for isolating or blocking these hazards. Apart from the obvious use of locks and tags, activities can range from the actual removal of parts of the equipment, including linkages, push rods, belts, and flywheels, to the use of items such as chains, wood and metal blocks, clamps, pins, hooks, and blank flanges for closing the ends of pipes. Many pieces of equipment also have their own built-in lockout devices. Clearly, lockouts can range from simple to complex, but all should be regarded as equally important. It is also important that everyone who is involved in either directly shutting down the equipment or working on the equipment after it has been shut down is properly trained, suitably experienced or qualified, and understands their role, and in particular their obligations for attaching and removing locks and tags.